Assalamualaikum warahmatullahi wabarakatuh. Thank you very much to Mr. Budiaswoyo and Mr. Dwianto, who has been the advisor for my final project proposal, with the title is Dual Band Microstrip Antenna Design of Mobile Satellite Services for NewSat 8 Satellite. Previously, I want to confide the result of my activities during at home. I read some journal and study of some literature and learn how to design a good antenna. So, I can complete this final project proposal. Here, I will present the result of my final project proposal. Thank you and keep watching. So, let me introduce myself. My name is Prabhavananda and my student number is 121-017-1038. The topic that I want to discuss today, there are first, background and research purpose, second, problem and problem limitation, third, supporting theory and literature review, fourth, methodology and timeline, fifth, system and implementation, and the last, expected result. As we know, main communication system in Indonesia using cellular communication system. It is using BTS, base transceiver station, as main backbone. Certainly, the system have some limitation. Sometimes, the system have problem like blank spot in certain area. Besides that, Pusdekshad 8 will launch a new satellite called NewSat, Nusantara Early Warning System, and this satellite will carry a new technology called MSS, Mobile Satellite Services. So, I make this project, Dual Band Microstrip Antenna Design of Mobile Satellite Services for NewSat 8 Satellite. And the technology will apply to a new system communication in Indonesia. This system has advantage compared to mobile communication system in Indonesia using BTS, base transceiver station, because the system communication using satellite is very better, because satellite can coverage very large area that allows user to access the system anywhere and every time without knowing have experience to blank spot. So, if the system apply to system communication in Indonesia, it will make system communication in Indonesia better. The problem for my final project there are how we design the antenna microstrip for dual band frequency and how this system works and what the specification we need to design this antenna. And my problem limitation is it is only discuss basic communication satellite only, and my working frequency only at S-band area, and testing parameter are the main parameter antenna, like return loss, VSWR, gain, bandwidth, and etc. For this project, I choose the type of antenna microstrip because this antenna can capture electromagnetic wave signal from satellite. The body of microstrip antenna include three parts. First, the patch, substrate, and the ground plane. In telecommunication, a microstrip antenna, also known as a printed antenna, usually means an antenna fabricated using microstrip technique on a printed circuit board, PCB. Most microstrip antenna consist of multiple pads in a two-dimension array. The antenna is usually connected to the transmitter or receiver through foil microstrip transmission line. Microstrip antenna have become very popular in recent decades due to their thin planar. Mobile Satellite Services (MSS). It is a new system that uses satellite as main communication system, and the satellite works as repeater. And the main parameter that we can observe from this project about the return loss, gain, polarization, bandwidth, and its work frequency. In telecommunication, return loss is the loss of power in the signal returned or reflected by a discontinuity in a transmission line or optical fiber. This discontinuity can be a mismatch with the terminating load or with a device inserted in the line. It is usually expressed as a ratio in decibel, dB. In telecommunication, an antenna's power gain or simply gain is a key performance number which combines the antenna's directivity and electrical efficiency. In a transmitting antenna, the gain describes how well the antenna converts input power into radio waves headed in a specified direction. In a receiving antenna, the gain describes how well the antenna converts radio wave arriving from a specific direction into electrical power. In telecommunication, circular polarization of an electromagnetic wave is a polarization state in which, at its point, the electromagnetic field of the wave has a constant magnitude, but its direction rotates at a constant rate in a plane perpendicular to the direction of the wave. In a radio antenna pattern, the half-power bandwidth is the angle between the half-power minus 3 dB points of the main lobe. When reference to the peak effective radiated power of the main lobe, see beam diameter, bandwidth is usually expressed in degrees. For make this project, I use a methodology. My methodology 2. First, a survey data. It is about the specification we need for this antenna, and design, simulation, and testing the antenna. And after I do survey data with my advisor from Pusteksat 8, I got the data. And the return loss for this antenna must under minus 10 dB, and the frequency work only at S-band area, and the polarization is circular, then the bandwidth is as big as possible. This is the diagram block of my methodology. First, survey data. I do survey data with my advisor, Mr. Budiaswoyo and Mr. Duyanto, and read some paper and some literature, and data input. If we got the specification, then we can design. Then optimizing the design. Then we can test the design that we made. We can use the software like CST Studio Suite. Then testing 2, it is testing the antenna when the antenna has been printed. Then data retrieval. This is testing the antenna at chamber room and at simulation process. Then analysis and conclusion. This is one of software that we can use to design and simulate antenna. This is CST Studio Suite. This is the proposed design that I chose. I chose slotted method paths because one of method to design dual band frequency is slotted paths. The size of slotted paths is adjusted to the calculation. Then, the MSS technology works as transponder to the satellite. It can receive, send, and strengthen the signal to be sent. So, user can read information and send information without having experience to blank spot. Expected result at the end, I hope this system can make system communication in Indonesia better and no shear frequency when the antenna has been printed. On the screen, it is the timeline of my final project. It's about 12 months. Thank you for watching this video presentation. I'm sorry if there are any mistakes. Wassalamualaikum warahmatullahi wabarakatuh.